Okay, welcome there. Let's briefly highlight and explain some important formulas that you use to answer question or get understanding about friction on a plane, friction on a flat plane. So look at this. This rectangular box here is a mass, or you can call it a block of wood that is resting on this horizontal surface here. Now, uh, as it's resting here, there is a force acting downward, and that force is the weight of this block of wood labeled W. Now, up here is R. R is called the reaction force. What we mean by the reaction force is as this block is resting on this plane, that means there is a force from this horizontal plane that is acting upward on this block. That force is what enables it to stay on that plane, to be at equilibrium on that plane. If there was no reaction force, the weight of this block would sink down the plane or break it. That's what we mean by reaction force. It's just like if you want to sit on a table. If the table doesn't have enough reaction force or a reaction force that is equal to your weight, the table will break and you will fall. So since this block of wood is not sinking this ground, that means the reaction force from this plane or from this horizontal surface, from this ground, is equal to the weight in this case, and that is what we call what? Reaction force. Where W here is the weight, which is a function of acceleration due to gravity and the mass of the body. Then here, this line here represents the direction of motion. So assuming that this block of wood is dragged towards the right here. So definition of friction. This is where friction comes in. F here represents frictional force, or you say limiting frictional force. So now the definition of friction is this. Friction is that force that opposes the relative motion between two surfaces in contact. Do I need to say it again? Friction is the force that opposes the relative motion between two surfaces in contact with each other. So if this block is to move, is to be dragged to the right, friction is that force that is trying to stop this block from, dragging to the right or moving toward the right. So friction force will act in opposite direction. That's why this F here is acting in opposite direction to where the force is being applied or to the motion. So that is how friction force acts. It or usually acts in opposite direction to where the actual force or actual motion is taking place. So that's how the labeling came in. So now what are the formulas or mathematical expressions that you use to analyze the frictional force on a block of wood resting on a horizontal plane? Now we know that weight W, we know that weight W is what? Defined as mass times acceleration due to gravity. Now, since we are talking about horizontal plane, that means this plane is not at an incline. Maybe when I mean incline, something like this, and the block is resting at an incline at a certain angle theta. So we are talking about horizontal plane this time, not inclined one. So since this thing is horizontal, the reaction force usually act perpendicular to the surface. Reaction force normally act what? Perpendicular to the surface of the plane. So like this one now that is an incline, if we are to draw the reaction force, this is how we draw it, to be perpendicular to the surface. You understand? And this one too is perpendicular to that surface. So that's reaction for the act perpendicular to the surface. So in this case now, since this block is not sinking down, that means the reaction force equals to the weight, which equals to what? Mg, mass times acceleration due to gravity. And then there is a term we call coefficient of friction. Coefficient of friction. Now, coefficient of static friction, labeled mu, in definition means is the measure of the roughness of the two surfaces or roughness of a surface when in contact with another one. Like if the surfaces have no roughness or they are perfectly smooth, the coefficient of friction mu is 0. But if the surfaces are very rough, that you have maximum friction, that means the coefficient of friction will be 1. So that means coefficient of friction ranges between 0 and 1. It can be more than 1 and it can be less than 0. So mathematically, coefficient of friction is defined as the ratio of the frictional force to the what? Normal reaction. So the ratio of the force, of the frictional force, that's the force that is trying to oppose that motion, to the reaction from the plane, will give you the coefficient of friction. What do we use this coefficient of friction to do? Like I said, we use it to measure the roughness. So different surfaces or bodies have their different coefficients of friction. So for instance, if we are to design a tire for a vehicle, they design the threading on the tire in order to maximize the frictional force on the tire, so that you can have the tire can have good friction with the asphalt or with the road or with the ground that is going to drive on. So this kind of topic, we apply them in designs of things like tire, belt, wheel belt, chain belt, things like that, so that you can apply the use of friction, or in brake pads. So different materials have their coefficient of friction. So if you want to design a brake pad, you know the kind of material that will give you the maximum frictional force, or by measuring the coefficient of friction. So that's by the way, but at our level, we are just looking at coefficient of friction is what? Frictional force divided by normal reaction. So that frictional force, if you make it the subject of the formula, it will be what? Coefficient of friction times what? Normal reaction. So this is the first formula that is very important when it has to do with a plane, when it has to do with a horizontal plane. So this is the first formula that's in this thing. So frictional force equals to what? Coefficient of friction times normal reaction. And the unit for the frictional force is of course Newton. Normal reaction is what? Newton. And then coefficient of friction has no unit because it's a ratio. It's a ratio, because if you see frictional force is a force, reaction is a force, they will cancel each other, and coefficient of friction will not have any unit. So this is the first formula you use to analyze bodies, the frictional force of bodies lying on a horizontal plane. So this is for when the motion is being, horizontal, when the force applied on the bodies on a horizontal direction. So what if someone dragged this body at an angle? And an angle, call it what? Theta. So now the difference when you are dragging it horizontally and when you are dragging it at an angle. Dragging it at an angle means you are pushing it upwards and at the same time sidewards. So it has components on two sides. So what will be the frictional force if you are applying a force at an angle to the block? Now remember, as this block is sliding towards the right, the frictional force will act in opposite direction like this F. So here we can turn to label it like this, so that if you bring out the triangle of force there, you see that is the direction of the force or tension on the string, and then your friction will act in opposite direction to that. Then you can cover this to be your normal reaction. So here will now be your theta. So there are sometimes you may be given question and then you have a block of mass that is resting on a horizontal plane, and then the force being applied on it is at an angle. So you have to resolve it into your triangle of forces like this, and then use any of the trig ratios that will give you that. Remember, this place is F, so that if you are relating T, or that's tension on the string, and F, or the frictional force, what will it be? Opposite, that will be cos. That will be cos theta. Adjacent over hypotenuse. Adjacent is F over hypotenuse T. So that your frictional force F will now be what? The tension in that string times what? Cos theta. So this is the second formula that is very important to calculate frictional force. So this second formula is for when there is application of a certain force or a tension on the block resting on a horizontal surface. When there's application of tension at an angle, you understand? It's different from this one that is an inclined plane. This one. So these are the two, three. So you watch the different past questions that we've answered on this horizontal plane question, so that you get to understand and appreciate what I just explained here. Thank you. Don't forget to subscribe. Thank you.